Hello, students. So we'll be continuing from exercise 3. So now we'll be doing exercise number 4, right? So before you start, you should make sure that your connection is established, right? And then after ensuring that your connection is established, right? This is done through ensuring that there's communication between your FLUIDSIM and your codices, right? So now you go to, gonna now check what exercise 4 saying, right? So exercise 4, the process is optimizing the inspection of beverage crates, right? So they're saying beverage crates are checked for completeness with the aid of an inspection unit, right? And then I think incomplete crates are pushed off the conveyor belt by pressing a push button, right? Which means like when they press the push button, the cylinder advances, right? And then they're saying problems occur repeatedly with this setup thus far. Right? They're saying the push button is not pressed long enough, and as a consequence, the stimulating cylinder doesn't advance to the front end position. The ejected beverage crates become jammed in the ejection area. Right? Develop a controller with which this program can be eliminated. Right? So, talking of the process saying the cylinder should advance as soon as the push button is activated. Right? And then they're saying there's the cylinder. Okay. Okay, so they're saying after a cylinder reaches the front end position, it activates a magnetic proximity sensor, which causes the cylinder to retract, right? And then they're saying use a double acting cylinder, right? So now going back to our FLUIDSIM, right? Here, like we can see that when we're using what you call the spring loaded 5-way, right? The cylinder retracts as an effect of the spring load, right? That it won't be able to retract instead of anything else. So we keep it in the advanced position as well because of the we're keeping it in the advanced position because of the what you call we're keeping it in the advanced position as a result of, can I put this? So we're keeping it in the advanced position as a result of the latching mechanism, right? So now here we need to be able to the cylinder. So when we're using this setup, right? Let's say we don't latch this here, right? So we're keeping it in advanced position. So you don't be able, you can't verify if it actually goes to the advanced end position, right? So now here, that's why we use the bistable, right? So before we move on anyway here, right? So here they are saying what you call the cylinder has the cylinder when it's advanced activates a magnetic proximity sensor, right? Which means we need to define a new input, right? So here, no, here, come here, right? And then we'll put a magnetic proximity sensor, right? So how you connect a magnetic proximity sensor is that this side, it goes to power, right? And then just move this a little bit down, right? So this side is connected to, just put it here. This side is connected to power, right? And then this side, you connect it to the input of the PLC, right? So you connect it to I3, right? And then now you are left with this part, right? So since ground is gonna cause, if you can, so this part goes to ground, right? But if you connect it to ground here, it's gonna cause like sort of like a mess in your thing, right? So you just create a new ground, right? So you just get a 0 and a 0 here, right? And then you rotate this by 180, right? And then you create another ground here in which you can ground this sensor here, right? So this is gonna be your new ground, right? So yeah, this is how you connect a magnetic proximity sensor, right? But anyway, moving on, right? So as I was saying here, right, it's not going back as a result of it's the cylinder when you're using the when you're using the spring-loaded 5-way solenoid 5-way, right? It's not retracting as a result of it detecting the front end position of the sensor, right? So it has no way of detecting the front end mechanism of the sensor, it is not able to advance to the front end position without us latching the signal, right? So which is currently one of the problems that they are trying to address in this exercise, right? So that's why you have to be able to detect the front end mechanism, right? So now when I label this FP, so FP is gonna be for detecting our front position, right? Which means now we're gonna get our distance ruler, and then we're gonna label this FP to the front end, which is at 100 and 100, right? And then that's okay, right? So now, since we are also trying to make sure that the cylinder retracts as a result of being able to reach the fully advanced position, right? We have to now remove this and then we use a bistable, right? This, right? And then let's say this is gonna be our Q0, right? And then this is gonna be our Q1, right? So now here we can now make the cylinder go back due to due to it detecting the front end position of the sensor, right? So now, since we've also have Q1 here, we're gonna get another solenoid valve, right? And then we're gonna define this as Q1, right? Okay, yeah, that's okay, right? So this is gonna be our circuit here, right? So okay, let me just try and address this. Right. So now I play, right? So going back to the problem, they're saying the cylinder advances when the push button is pressed, right? So when I0 is pressed, so come here and then you say I0, right? It activates Q0, right? And then now we latch that signal, right? And then now we put in our stop and emergency in. As always, I'm sure now by now you pretty or you know the reason why you have to always put these ones on, right? So you put in your I1 and your I2, right? And then now you also define here, you also have to define your Q1, right? Which means you come here, Control V, Q1, like this, right? So it's gonna be a solenoid one, right? And then, oh, since you've added a new input here, you come back here to build, reselect, and then build again, right? And then now you simulate this, and then go back here, right? So now I'm just gonna remove this because it's not necessary at this point, right? Now you can see our cylinder fully advances, right? Right. Oh, I'm just trying to trace something. Okay. So now one thing you also have to do right here, right? So now at this point when the cylinder is in the rotated end position, right? Q1 it's on, right? That's what's keeping the cylinder. So if I play this, right, as you can see, air is coming from here to here, right? Which means Q1 is currently on, which means it's allowing air to pass through to keep the cylinder in the rotated end position, right? So now when you activate this, when this gets activated, right, it becomes on. Air has to come in this side, right? So air can't come in through both. So that's why you have to turn off this one, right? And how you turn that off here, right, is that you insert an output, right, and then you put Q1 here, right, and then you negate it like this, right? So now here you are saying, like, when you press I1, right, you want your Q0 to be on, but at the same time you want your what you call your Q1 to be off, right? Which means now, since this is currently on in this state, right, when you press the start push button, this will turn off and then this will turn on, causing your cylinder to advance, right? Because if you don't turn this on, right, it will, this and this will be both on, and then as you can see, like, it's gonna be somewhat like, in layman's I can say, it's gonna be someone, it's gonna cause like some, like, sort of a conflict, because this is gonna be on, which is telling the cylinder to be in the right side in position. This is gonna be on as well, forcing the cylinder to advance, right? So you have to, like, they can't both be on. One has to be off, one has to be on, right? And then now you wanna insert this cylinder, right? It's gonna, so that the sensor can retract, right? So you come here and then you insert your I3, right? So insert your I3. So it's gonna be your I3, right? But since your I3, it's not currently on now, which means if you put it like this, current will not pass through, right? Therefore, you have to negate this, right? And then you log in, and then you play, right? So as now you can see Q1, it's on, keeping the cylinder in the rotated end position, right? And then when you press the start push button, this has to turn off, this has to turn on, allowing the cylinder to advance. See the cylinder is retracting as a result of the sensor 10. So that's your solution to exercise number 4, right? So now we move to exercise number 5, right? So in exercise number 5, they're saying bottles need to be diverted in groups of 3 from one conveyor to another by means of a divert, right? So they're saying after being switched on, the system should run continuously, right? It should not be switched off up until a stop signal is generated, which means the system is running continuous up until you generate a stop signal that stops the entire sequence, right? And then the sequence is started by pressing a push button, right? And then, like, they're saying if there are 3 bottles present, if there are the 3 bottles present, if 3 bottles are present in the rotated end position, the cylinder is advanced. So right now, for a cylinder to advance, it has to also be in the rotated end position, right? And then they are saying the bottles the bottles are diverted and transported to a second conveyor belt. And then they're saying the sequence is stopped through the use of a second conveyor belt, right? And then now, as you can see here, right? So first, now we need to make a system that run continuously, right? And then they're saying that the system, like, it has to advance fully to the front position and then go back, right? Which means now we need to also define the reset end position, right? And the front end position is going to make the cylinder retard, right? So we come back here to our distance ruler, right? And then we define the back position, which is 0 and 0, right? And then now, let's say we're using a magnetic proximity sensor, right? So if I can just, so now I can extend this to here, right? Yeah, this is okay, right? And then I come back, I insert right. So now let me just try and move this down. Not. And then, yeah, this is how we put in our sensors, right? So now make sure that your connections are correct, right? So now you can also maybe try and move this down, right? And then I'll define this sensor, which is sensor. Okay, I've connected it to the wrong port, right? So connect it to I4, right? And then I'll call this sensor the back position, right? Which is BP, right? So now, coming back here to the question, right? They're saying the sensor started by a push button, right? But then they're also saying like the cylinder also. So now, like for you to start the sequence, right? There's only one condition, right? You have to press the push button. That's what initiates the sequence, right? But then, like, you have to. They're also saying like if there are three bottles present in a certain position, that's when the cylinder advances, right? But you need to create what you call a line for what starts the sequence, right? So what's starting the sequence? So if I can just delete all of this so you can start afresh, right? So they're saying the sequence it's started by a push button, right? So we'll create a memory, right? This memory is what will initiate the sequence, right? So I'll put an output, right? So I'll create a memory called M0, right? And then obviously I'll have to save that memory as a Boolean variable, right? And then now I will flash the signal of that memory, right? So I will insert like this, right? This is gonna be your M0, right? And then I put my stop, emergency stop, right? Which is my I1 and my I2, right? And then now, since I've created that memory, right? So this memory is what's gonna initiate the sequence, right? And then now, like the second part of the statement is saying like the cylinders, like the cylinder only advances that three bottles, right? See if there are three bottles present, right? So now I have to what you call I have to create another memory, right? In this memory, right? This memory will contain the backend position, right? So let's say for argument's sake, right? So let's do some modifications to this question, right? So there maybe let's say it's advanced. Let's say there's incident advance after 3 seconds, right? cylinder advances after 3 seconds. Right? So you have to create another memory, right? That's gonna contain the back end position, right? And the memory of the time, right? So now you're gonna come back here, right? So your back end position, it's gonna be what? It's connected to I4, right? So you're gonna say here, gonna create another memory, right? That memory is gonna say I4. It's going to be I4, right? And then you go to your function block elements, right? Okay. So one thing also forgot, right, is for you to put I4 right here as an input, right? So you're going to come here, you're going to put I4, right? As this is now going to be magnetic proximity sensor 1, magnetic proximity sensor 2, right? Since now we have 2 magnetic proximity sensors, right? And then you're going to get your RS component that's going to be used to latch our time, right? You also want to like define it and make sure you save it as an RS time, right? So don't use SR, use RS, right? And then now you get your time, right? And then you also save it as ton, so it's a ton variable, right? So make sure that's correct, right? And then you cancel this out, right? And then this is gonna be this side, this is gonna be your output, right? And then here gonna put, so you wanna reset your timer using I1, right? And then you wanna reset your timer using, so insert parallel below I2, right? You wanna reset your timer using what you call, when I set it using the start and emergency stop, right? But then since your I1 and I2, they are always on, it means they're going to be always sending a signal to your timer to reset your timer, right? So now here you have to negate them, right? Because if you don't negate them, they'll be continuously sending a timer, sending a signal to your timer, telling it to reset every time, right? And we don't want that, right? And then now we put our time here. So time, they said it's 30 seconds. So T hashtag as 3S, right? And then now this is gonna be our second memory. This is gonna be our M0, right? And then we are going to insert like network below, right? And then here we are gonna say, so here we are gonna say after that memory, right? So this is where we're gonna fulfill those two conditions, right? So the two conditions are saying, right? So let's just go to your output and then we latch, right? So the first output is saying that now our start push button, right? So which means our I1, right? Not our I1, sorry. So our I1 is equivalent to our M0 right now, right? So we'll say M0. All right. So I was saying like now you put that memory of I0, right? So now it's gonna be your what you call your M0, right? And now since they said here the sender has to be in the retractor endpoint for it to advance, right? So the second condition is your M1, M1. So this is supposed to be M1. So right, and then you save it as a pool variable. So these are the two conditions, right? And then this is gonna be your M1, your Q0, right here, right? And then now this is gonna be when I insert two calls, right? As I said here, since we're dealing with the bistable, right? When this one turns on, the other one has to turn off and so forth, right? So this one here, you wanna negate it and then put it as your Q1, right? And then this one is gonna be your Q0, right? And then after you are done, you have to now add your start and stop, right? So you insert your your stop, which is your I1, right? And then you also insert your I2, right? And then now, since they said the cylinders only retracted when the cylinder, like the process, since the system is running continuously, right? The process stops when a stop signal is generated, right? Which means, like now here, for your sequence to be looped, right, and to ensure that your cylinder fully advances, right, you have to use the front end sense, right, which is I4, right here. So you have to insert I4 here. So that I4 is what's gonna retract your cylinder, right? This ensures that cylinder fully advances to the front end position, retract, and then advances again, right? So you're gonna put in your I4, right? Is it I4? Let me just verify. It's I3. You wanna put in your I3 here, which is takes the front position, right? And then you are going to negate it, right? So that, like, because at this point your front position, it's not gonna be on for the cylinder to retract, right? So now you have to negate it to ensure that this current passes through so that the cylinder can advance, right? And then after you are done, you build, you reselect, and then you build again, and then now you log in, then you log in with download. And then now if I play here, okay, small issue. So now if I play here, right, so now this is what's initiating my process, right? Not two conditions, right? Advance, then for so now so the said it's only gonna start the stop when, but which means that we to reset. Right? So in this, I'm gonna set my front end, right? I should because now set the I, right, to indicate was in this now point 10, and then give it, and then let's just start afresh everything. Things currently resetted now, right? So now, as you can see, my sequence, it's not even like on, you can see M1 is currently on, right? But my M0 is not currently on because my M0, like, it's what starts initiates the sequence, which means I have to activate it here to activate M0 for the sequence to start, right? So now if I press this, in that, right, that's again for 3 seconds, advances like count second what advances and advances are, right? So my system is running completely faster and stopping my system now, right? It's being stopped by when I hit the stop, right? Generating the stop and stop now, right? And then my timer resets, right? And then is awaiting the next part, right? So now let's say if, like, if they said like, because you saw I made a modification here, right? So now if they said like the time, the cylinder doesn't advance after 30 seconds, right? What you would have done is that now there would be no need for the timer. Instead, you would have taken I4, right? This I4, and you replace it with, so you replace this M1 right here. So you put I4 here, right? And then now the system will, okay, let me just maybe like try it and like, so you see how it works, right? So now you would rename this to I4, right? Which means like the time, we're not using the timer anymore, right? So the system like will advance without delays, right? Advance and track without delays, right? So now I log in, then I log in with download, and then I play. Right. And then when I press start, see now it's complete the of the, right? Not now waiting with regard to time, right? It's advancing. So now that's, now you can like with right, remove right there, put this, so you can try your own and see the system without what you're